Please welcome our first panel session of the day, Manufacturing Technology Game Changers. Please welcome our speakers, Dr. Ray O. Johnson, Senior Vice President and Chief Technology Officer, Lockheed Martin. Dr. Charles F. Kahle II, Chief Technology Officer, PPG Industries. And Dr. Mark M. Little, Senior Vice President and Chief Technology Officer, General Electric, and Director, GE Global Research. And please welcome our moderator, Dr. Michael Crow, President, Arizona State University, and University Vice Chair, Council on Competitiveness.
Well, good morning, everyone. I've been asked to let you know that there'll be no breaks today. There'll be, each of you will be getting catheters shortly. And they'll be provided to you by the Lockheed Martin Corporation. So what's really exciting is to be with three individuals who are the chief technology officers, that is the senior thinkers about where these corporations are going and where technology might be headed, of three fantastically successful corporations, Lockheed Martin, PPG, and GE, trapped in a room, unable to get out of the room to come out here onto the stage. And so we've got a lot of pent-up energy. And I'm going to start with trying to get the coolest thing that you think is going on, that will affect something related to energy or manufacturing. And I'm going to throw something out. Way back at the ranch at the university that I'm a part of, Arizona State University, we just had one of our chemists just put together a femtosecond X-ray crystallography tool. Don't worry about the tool. She just applied it to the photosynthesis crystal structure inside living organisms on Earth and observed, therefore mapped, and therefore can replicate the system in which the hydrogen atom is busted apart in the water molecule and a photon is transferred into the molecule from which sugar is manufactured. And once you understand that and how to replicate that, you've really got something going on. So way down the chain from you guys are unbelievable tools and unbelievable insights and unbelievable perspectives that just are tremendously exciting about energy and what that might mean for manufacturing. And going to the Secretary's comments and the Assistant Secretary's comments and others, Chad Holliday's comments, I mean, we're really at this precipice. But let's start with, what is the coolest, most exciting thing that you know that's going on somewhere, either in your company or anywhere, in this area of energy or manufacturing? We can start with whoever wants to go. Mark, you want to go first?
Sure, okay. So people love to ask me, as CTO of GE, with the breadth we have from healthcare to energy to transportation, what's the coolest thing we do? And it's always a tough answer because industry by industry, we have incredible innovation. But I would say the broad trend for what we call the industrial internet and building the connectivity of devices and the opportunity to manage big data in ways that couldn't be done before is opening up incredible opportunities in servicing equipment bases and in the manufacturing side as well. Both of those two things are very, very powerful. So we're able to sweep information through our factories faster than ever, across our supply chains better than ever, and it drives incredible opportunities for productivity.
So how does it change behavior when you've got this Internet of Things, you've got unbelievable data flowing back and forth? How does it change behavior in the factory floor? How does it improve efficiency? I mean, how does it work?
So we have factories all over the United States, all over the world, and what we're doing is driving prototypes in each of these big factories to show what we can do and then share best practices across the company. And what's happening is this is building real momentum and a real revolution in our manufacturing and supply chain base.
So the speed of innovation, the learning, the rates.
Getting much faster. And along with this, because you have this kind of innovation and fundamental things going on the material side, we're seeing opportunities to innovate, and that's driving us to rethink our long-standing practice of sourcing everything.
Yeah.
We spent most of my career finding global suppliers who could do things at very low cost. And now we're seeing, with this gain in momentum and innovation, we can do a lot of proprietary things. We're actually insourcing. It's a huge change for us.
So I think everybody needs to take a really, really, close listen to this. Innovation is speeding. Innovation is enhancing insourcing capability. Innovation means drawing manufacturing closer to your knowledge source and your information source. So Chuck, how about you, either at PPG or anywhere?
PPG, for a lot of people aren't
Let,
familiar.
let people know what PPG is,
Yeah.
how many people know what PPG is? And be honest. Oh, that's not
Now
honest.
keep your hand up for a moment. How many of you think that's P&G? A lot of people confuse us. So PPG's a fantastic materials company. We are the world's largest coatings company. We're involved in other areas such as optical monomers, fiberglass, glass for residential. We serve a lot of B2B and B2C markets. And really, PPG is sort of that hidden technology that's probably present no matter where you are. If you have a BlackBerry or an iPad, you have a PPG product present. So we coat those things. We make them more efficient. And the things that I'm seeing in the marketplace, and the thing that I'm most excited about is the changes in energy are driving profound changes in the manufacturing base. And those changes represent product opportunities for PPG. And whereas historically, PPG's portfolio was dominated by environmental considerations, so eliminating solvents and things like that, today, the majority of our products relate to energy in one way or another. And
So talk about how does the majority of your materials company's products relate to energy? Just talk about that.
so we look at trying to reduce the energy footprint of an automotive fabrication plant. 70% of the energy utilization in a fab plant is tied up in the paint shop. And we're introducing products that can save 30% of the energy use in a fab plant. And the globalization of this technology is taking off today as an example.
Mm-hmm.
In terms of a material that gets me excited these days, I'd say if you think of coatings, we're material science in 2 dimensions. And the material that's really interesting to me is graphene today. You look at what graphene's potential is for...
Well, just for everybody's benefit, there must be 1 or 2 people other than Deborah that don't know what graphene is.
Okay. Think of chicken wire on an atomic scale.
Chicken wire,
Only carbons.
atomic scale.
Only carbons in each of the corners, each of the intersections. And if you had a hammock, a sheet the size of a hammock, it would support the weight of an elephant on the end of a pencil. Enormous strength properties, very interesting conductivity properties, has application in things like lithium-ion batteries. Mm-hmm. So it's the application where you talk, the intersection with energy, and as an example. So we're looking at, we've actually developed a process for mass producing it, which is very interesting, is finding application in a lot of the energy spaces, as an example, in lithium-ion batteries.
Okay, so Ray, how about you from your point of view?
I'll take you someplace a little bit different, a little bit of an extension of Mark's comments about the Internet of Things, something we call the digital tapestry. And the connection that I think comes about, energy for manufacturing is important for us, but it's not the real important energy aspect. The important energy aspect is what's empowered and enabled by the combination of advanced manufacturing and material science. Changes in material science, in nanotechnology and other metamaterials, graphene, other material changes, and then coupling that with advanced manufacturing. And I think in a future question, I'll tell you about some of the challenges associated with that, but the advantages are that you can get to size, weight, and power that you can't get to with traditional materials and traditional manufacturing processes.
So give an example of that, size, weight, and power.
So you might think about the cost of launch. The cost of launch of a spacecraft scales with weight. And so by reducing the weight, you reduce the launch cost. If you have an airborne platform, by reducing the weight, you can increase payload or loiter time or things like that. So we're finding that the combination of this digital tapestry, which is the digital thread that Mark was talking about, from the concept through the design, through the engineering, through the production, and even through sustainment, that's a digital thread, and that makes a lot of sense. But now, flowing that down to the supply base, so that you have a digital tapestry, so you're flowing it down and across, and then working within that digital environment, you're able to, we talked earlier when we were waiting to come on about what keeps us up at night, and so of course the supply chain and quality are big issues. It helps ensure that quality, it helps balance lead times and issues like that. So I think this Internet of Things, the digital tapestry, the digital connections, as well as the advanced manufacturing capabilities that are being developed worldwide, and advanced materials are going to enable a corporation like ours to achieve big advances in size, weight, and power that will result in enhanced capabilities and affordability, which everybody knows is important for the customers that we serve.
So Ray, let's follow up on the supply chain idea, but it's not the supply chain of stuff. What is your supply chain for idea production? What is your supply chain for solving problems in this very integrative technology platform company that you're? What's the supply chain for ideas?
For idea supply chain, well, two things come to mind. We have, well, three maybe. We have a corporation of 113,000 people, and roughly half the people in the corporation, engineers, scientists, and technologists. So it's an engineering technology company. So therefore, those people tend to think in problem solving in innovative ways. We also have a group of about 350 people that we call the technical fellows. Like GE has a fellows program, many large corporations do. So these are fellows and senior fellows, and they represent less than 1% of the technical expertise inside the corporation. And they are really, the people who wrote the books, the experts, and they're the idea generators, and they're paid to do that. And then also, we have really good relations with universities where we bring in we make partnerships, develop partnerships and agreements, and then bring in those ideas, and that really supports this ecosystem of innovation, going from the invention, that is the creation of the idea, through the innovation process, the application of the idea to products and services. And even in our fellows, they're more thinking about the innovation, not the invention. If you go to universities, that's where things get invented. Small businesses, things get invented. So that partnership allows us to complete that ecosystem.
Okay. Chuck, what about your ecosystem for ideas?
It's really, you hear the concept of open innovation. It's not really formal, but it really involves meetings like this, getting outside of your core, looking beyond just what you traditionally think about. To us, it's an intersection between the changes in materials and substrates that are taking place and what kind of materials we can bring back to solve those problems. So we look to suppliers for innovation significantly. We look to partnerships with government agencies to really lead on some of the more leading edge technologies, bringing new technology in through the universities, very much like what Ray was saying. So we have relationships.
Does anybody still read a scientific journal over there?
Yes, they better. But it's all electronic now, so they can read anytime and anywhere.
Right.
So we enable that. But really, it's exactly what Ray was saying. We have the same kind of structure, but it's a much more open environment today. And the data that's available, the information that's available, the key difference is the speed, and the speed of decision-making has changed dramatically on what to do to solve a problem.
So Mark, you're leading among many things, you're leading one of the most significant human constructs, the corporate, American version of a corporate R&D laboratory. In your case, it's been around more than 100 years. It's done fantastic things. Its history is very storied. What is your idea supply chain into that 100-year plus iconic structure?
So as you noted, we have a great foundation to build on. We got a lot of smart people in the research centers tied up, focused on company interests and customer interests. For us, it starts with customers. We have very methodical processes for engaging with our customers across the industries in which we play. And so they help us formulate ideas about what they need for their future. And then we try to engage, as my colleagues were saying, with the government labs in a way that's much deeper than we used to before. The cooperation is much better. The sharing of resources and ideas is profound now. Wonderful university connections. We work with small companies in a new way. We used to work with big companies and still do it very natural for us to do that. But we've engaged with small companies. We even have venture capital activities that are aimed at getting us connected with the world's emerging technologies.
As they emerge, so
as they emerge,
quickening
so
that
see what's
speed,
going on. It used to be little companies be afraid of big companies like GE. By being a VC investor, we get a minority position. We can help them, and we use our distribution and our technology strengths to help them grow. And lastly, we've been doing real open innovation and a call for ideas and actual product generation. A good example of this is we had a call for ideas around the world for people to help us develop a component for an aircraft engine. We asked them to use 3D printing to make the component to help us generate some thoughts around that. And a young man with not a whole lot of technical training in Malaysia actually won the competition. And we got 9,000 people from around the world, all corners of the world. That's a whole new source of innovation for us. So we're trying to tap every source we can.
That's interesting. Are the others doing stuff like that? I mean, it's not the same sometimes in defense-related spaces, but a little more constrained there. So you don't know what the guy will send over your 3D printer. So Ray, talk about, I'd like each of you to describe, we talk about this, I'd like each of you to, it's 2015 roughly. let's just say 2025. Who could have imagined? No one can even imagine the year 2025.
That's a song, isn't it?
And it is, yeah. And it goes all the way to 25. But so, and it doesn't have a good outcome, by the way, that song, if you remember. It's kind of technology run amok song. And so, give me your sense of how fundamentally different do you think it will be 10 years from now versus just 10 years ago? Are we on sort of a flat, very intensive technological change paradigm, or is something more dramatic happening?
I think something more dramatic is happening. I think that we're on the cusp of change. And in each one, we have 5 business areas in the corporation. In each one of these businesses...
Well, just let everybody know, since they might not know what those 5 are.
Well, I'm not going to go through the list, but there are 5 major product areas, and you can think of them as being $8 to $10 billion each.
Starships, phasers, what else?
Exactly.
Yeah.
Photon torpedoes, right. So, aeronautics, space, and things like that. In each one of those businesses, we're working on, there's essentially a team of people who are thinking about what the factory floor of the future looks like. And not only what it looks like, but they're developing plans for implementation of that future factory floor to include advanced manufacturing and other enhancements to the manufacturing process that can bring about higher quality, lower costs. That's what's driving us to do that. A better quality, a lower costs, and a smooth flow of products. The fact that they're not just thinking about it, and they're actually developing implementation plans that are happening today, right? We have components that have been 3D manufactured that are on products today. I think as they get implemented and the lines change, we will see in 10 years a dramatic change in what that factory floor looks like. And let me just mention, while we're on the subject of getting there, one of the issues with getting there, this is a great story. I think it talks about how engineers think. So as we're developing 3D manufactured parts, imagine that there's a component that looks a certain way and has some functionality. And so you ask the engineers to 3D manufacture this part. Interesting to me is that the 3D manufactured part looks a lot like the part that was manufactured with the boundary conditions of current manufacturing techniques. Then you say, go back and think about the functionality of the part. What would it look like then? Well, the interesting thing is, after you go through this process 3 or 4 times, the part that is manufactured by the additive process looks very different than the part that was designed with the boundary conditions of manufacturing today. That's a real challenge for us. Why is that a challenge? Because you have to essentially retrain engineers to design without the boundary conditions of current manufacturing process.
That's an extremely important point. One of the things that we face at the university, we have 17,000 engineering students at ASU, and we're realizing that the rigidity of the education process has not allowed us to produce the kinds of engineers that will be needed for this whole new way of thinking. So that's
correct. So you have to retrain people to think that way, and you have to develop the workforce of the future that goes through that in their educational process. They learned how to do that and think differently, because by doing that, then you get a part that has a lot less material, right? And size, weight, and power improvements can really be achieved. So that's really important to that first thing I talked about, is what that future looks like.
So then that deeply affects the outcome of what manufacturing will look like, what energy demands will be, all of these things. And it's kind of a flexible, adaptive way of thinking about everything.
The time that you save the most money and have the most impact are on a small number of very complex parts.
Right.
So you can think spacecraft rather than maybe 4,000 of a particular production system.
Right.
The different techniques can be used there.
So Chuck, 10 years out, is it dramatic change? Very dramatic change? What do you think?
Very dramatic. At least in the spaces we deal with, what I see happening is a merging of functionality. So we're all used to our smartphones and our iPads, and we are familiar with that surface, but imagining all surfaces interacting with their environment in some way or another. And what I see in the coding space, and our customers are asking for this, is enhanced functionality. When you think of paint, this isn't the first place you decide to send your kids into industry, right? You think paint. Paint, what's paint? But actually...
How many are going to send their kids into paint?
But coatings are some of the most sophisticated technologies out there, and what's happening is they're becoming multifunctional.
Yeah.
And they're going to continue.
Well, give us an example of the multifunctionality of an advanced surface.
Think of aerospace and think of a composite plane. You don't want temperature excursions beyond certain extremes to preserve the integrity of the plane. Imagine a paint. You think of it in terms of color, gloss, appearance, texture, but what about IR reflective? What if you want a black plane or a darkly colored plane, but you want it to be as cool as a white painted plane? And we've invented technologies and developed coatings technologies to do that. So the surface skin of a plane will be the same, of a dark blue Southwest Airlines plane will be the same as a white painted plane. So that's an example where you're building additional functionality. It may not even be perceived by the customer directly or the consumer.
So what do you think is the biggest, what will be the biggest change? So
the biggest changes are really going to be the merging of electronics with paint. We're very good at dispersing pigments, and if you imagine electronics at the scale of a pigment and an ability to disperse those, now you have a network that's monitoring whatever conditions are necessary for the room, the car, the plane.
what about moving even beyond that into biological systems, which then
Absolutely.
makes...
You talk about aerospace. Aerospace perceive, their vision, their longer-term vision, they're a customer, is to have the skin of the plane be like the skin of a human. It self-heals. We're developing self-healing technology. It senses extremes, temperature excursions or pressure or stress, and it feeds back to a central computer. I'm imagining in 10 years you will see coating systems that do all of these things. But it's a merging of, it's not just the resin chemistry in the paint, but it's a merging of the electronics, the information systems, and the coupling of all of that to an intelligent center, a computer, a chip, a brain. So you begin to anticipate failure on a structure. You have critical things like pipes, and you know what's going on underground even though you can't see it.
Yeah.
The paint's actually feeding back to a computer and telling you the structural integrity of a car.
So it's all about integration and connection and so forth. So Mark, your lab's been around for over 100 years. It'll still be here 10 years from now. How will it be different, and what will it be doing to affect outcomes related to manufacturing effectiveness, energy systems, energy system effectiveness? What do you think is going to happen?
Well, these two areas you're talking about have been core areas for us for 100 years.
Right.
And our focus now is stronger than it's ever been, because the fundamentals keep going our way to make these things just much, much better. So I see tremendously great things. I talked about what we're trying to do with our factories, with the industrial internet and the connectivity. But beyond that, we're doing things in fundamental material science. 3D printing is the sexy example that everybody sees, but there are many technologies beyond that that are opening up new doors for us. And as I was saying earlier, because the technologies are so profoundly interesting and complicated, we're choosing to build these things ourselves. We're building our own factories. We're doing these things, many of them in the United States, close to where they were invented. And that's a really terrific thing. And on the energy side, I just see tremendous progress still to come. A near-term thing that will probably take 10 years to get to full fruition is an area we have around solid oxide fuel cells. This is something we developed over years with the Department of Energy, and we got a fundamental material breakthrough in the manufacturing side that's going to enable us to make those systems at a very low cost and very high efficiency. And what it will enable is a shifting of the paradigm. For my whole career, and really forever, central station power plants have been the most efficient way to go. With this technology, you take a solid oxide fuel cell and put it with a reciprocating engine to burn the residual. You can get 65 to 70% efficient systems in a distributed way, whereas central stations today talk about 61 or 62% efficiency. It's a tremendous shift, and this is really going to happen.
Before distribution.
Yes, you're right.
They lose a little bit more after
Absolutely right.
So let's switch to this whole idea of, it's kind of like, it's funny, we're walking along and then we stumble, we don't stumble, but we stumble across this notion that somehow all this stuff is linked together, that our energy security, our national security, our manufacturing success, our export success, our economic competitiveness, they're all, intertwined with each other. So what's going to hold us back from being unbelievably wildly successful now that we have the internet as a platform, now that we have these kinds of organizations that you all are leading? What holds us back from wild success at this intersection of manufacturing success for the American economy and energy success for the American economy coming together? What holds us back? Anybody?
I'll start. I don't see much in our way because I think we've got the fundamentals there. We've got a great ecosystem of innovation. We've got a lot of smart people. We have an entrepreneurial spirit in the United States that's absolutely terrific.
You guys might notice that all this stuff is positive and powerful. It's not what people write about in newspapers. It's the funniest thing. Keep going.
I was going to get to the things that I worry a little bit about, though.
Right.
But I think there are fewer things that I worry about than there are things that I'm positive about. So things that I worry about is having the STEM foundations in our society to feed what we need.
Right.
And I worry about regulation a little bit, too. I see in the healthcare space a shift to do things in Europe as opposed to doing in the United States because the FDA is so restricted.
In terms of getting devices built and everything.
Yes, so many people are going to Europe first. That's worrisome.
Yeah. Chuck?
We actually see, I'd say there's more upside in what we could do. I agree, the infrastructure's there, but we need to go faster. We need to be more deliberate in what we're going to work on.
So what can help us go faster?
Strategies, clear governmental strategies around energy policy, drive very important decisions on where we invest, and understanding where we want to focus as a company, as a country, and as a company. And that overlap we can respond to, but if it's unclear, then it becomes more problematic on where to invest.
Okay. Ray, you want to comment on that?
Yeah, I think what comes to mind is risk tolerance and investment and thinking long term. So maybe it's taking a strategic view. In Chad's presentation today, he said we can have both, right? We can have, take climate change as an example, or resource management integration. We can do these things that are necessary and make the investments, and we can also have good business as an outcome. And I think that's the challenge is creating a business case environment where the short-term outcomes don't drive behaviors that really can be achieved in the long run. And I think, and also I think, so that's for the U.S., but I'd like to also address globally the challenges in energy, this nexus of, we haven't talked much about water and food, and the link to manufacturing is pretty clear, and that's what we've been discussing. There's also a very strong link to food and water, and I think that's, for the rest of the world, probably much more important than the manufacturing side. And there, you have to have a infrastructure and central governments that are able to step up to these challenges, much in the same way. It's really the alligators that are closest to the boat. And so how does the world take a longer view about these long-term investments that have to be made? What's the role of the United States on a global scale for that? What's the role for developed nations versus emerging economies, and how do they work together to solve the global problems? Because the world is now so interconnected. Their problems, whoever they are my problems, right? It's a very interconnected world, and of course we're connected from a resource point of view. So having the United States take a leadership role on the global scale, as well as not thinking too short term, I think are the answers there.
So you guys are obviously, by function of survival into the roles that you're presently in, that's a rough process that everybody goes through. Some of the smartest, most creative, most adaptive corporate technology leaders that the world has ever produced, because you're doing things beyond whatever anybody did before. You're standing on their shoulders, obviously, and moving forward. And so what do you think is, like on STEM, you brought up STEM education. So we're finding that when we go back and look at how we teach engineering, we find out that one of the problems that we have with getting more kids interested in engineering is our faculty. They're not adaptive quickly enough themselves. So you've got to change pedagogy, change structure, we eliminated all 11 of our engineering departments and created theme-oriented, global challenge-oriented engineering schools. We have then dramatically altered with massive increases in gender diversity and ethnic diversity into our engineering school as a way of moving forward. So you guys are out there, and you're in a sense at the tip of the spear of American technological success, both in manufacturing and energy systems and other integrated technology systems. Why is it so hard to get people to understand that it is change that is the means to our success? It is our adaptive skill that is the means to our success in all institutions, be they big technology corporations or universities. Why is that so hard for people to understand. Now, I'm moving into your softer side of your thinking here, but start with you, Mark.
You're asking a big question here. And,
Yes. But you guys are the geniuses in charge of these things, so we need answers.
Yeah. In the world I live in, people come to work in the environment because they love change. They're trying to do something different.
So they're self-selecting
They're
into that,
self-selecting because they see the ability to make the world different from the way it is today. So not enough.
But how do you spread that?
So I think we do our best to try to engage our communities that we live in to help the young people see what's going on. There's certainly an untapped resource in the United States with the young women who don't have enough exposure. Getting them into the system, I think, can be a big plus. And I think that's happening, but a little bit more
Half the engineering faculty members we've hired, which is almost 50 in the last 2 years, are women.
Great, great. They need more. We need more role models there. So a lot to work on.
Yeah, Chuck.
You touched on a lot of it. It's really relates to retaining people in this country. You look at my alma mater as an undergraduate. I'm not sure any Americans entered the chemical graduate school in the last recent years. The ones that are foreign-born, they are returning more to the countries of birth. It's attractive. There's an environment of investment, and it's exciting growth opportunities. I think we have to work better at creating a better environment in the United States and a better vision in terms of how exciting it can be. Now, I just want to flip it around and say we are finding excellent students coming out of the schools today. I think their educations are excellent. Still some of the best in the world, and we're really benefiting from that. Then, two, I just want to touch on the diversity aspect. We're not doing enough. We're not doing enough as individuals, as corporations, as in a country, in really enhancing the pipeline of underserved populations and increasing the rank in the sciences, especially African American, Hispanic. They're underrepresented in our pools, and we very much recruit that way, look for those candidates, but why that is, I can't really say. Then the last thing I'd say is we got to continue to get these kids at a very young age. I serve on the board at the Carnegie Science Center, and I see what happens when you get these kids' attention before they go into middle school and high school. It's so critical then to really get their interest and engagement. And I think we need to continue to invest that way in terms of science centers, preschool, or not preschool, but pre-high school, pre-middle school.
Yeah, if you don't have them by the fourth grade, it's hard to.
It really is.
Yeah, so Ray?
We get what we celebrate, right? We celebrate movie stars, we celebrate athletes. We don't celebrate engineering. And, and I think for a few decades, the pathway to riches, the pathway to success has not been well defined, certainly well articulated by a pathway in STEM-related fields. And so I think we have to change, and I use the bully pulpit of the Chief Technology Officer in Lockheed Martin to change that every day I can. Right? We are the host and founding sponsor of the USA Science and Engineering Festival, which held its third event in Washington in the spring of this year. But we have to celebrate it. And your comments, Chuck, are exactly right regarding diversity and regarding mobility. We have to think, and education. Education has to change, right? The MOOCs may be an indication of the beginning of the change, but education has to change. Sitting in a let me talk to you guys, right? Sitting in a classroom like this being lectured to is not the best way to learn, especially something like engineering that tends to be more hands-on. That's why the festival that had 3,000 hands-on exhibits gets kids excited. They don't fall prey to, physics is difficult, I don't know calculus. They get excited by the fact they're doing hands-on things. We also have to accept the fact that we have a mobile society, mobile generation, that isn't going to go to work for GE or Lockheed Martin and stay for 40 years necessarily. They want to move around, they want to do different things. And the diversity comment is absolutely critical. We have to have a workforce in the corporation that looks like the background. And because it's a science and engineering company doesn't mean that it still doesn't have to look like the background. So we have to attract more people, underrepresented groups, women, minorities, into science and engineering fields. We have to do that. It is absolutely required for our nation's survival, because we are going to ultimately, all the baby boomers in this room, we're going to ultimately retire. And where is that next generation to come in behind us in the numbers that are required to be globally competitive? Because there are people who are studying MIT classes in a village wherever, and they're real hungry and they're working really hard, and they're going to be able to compete on a global scale through the internet.
Yeah. So let's just think for a second. What is the, in this space of manufacturing and energy systems, what do you think is the sweet spot? Is it integration, which we've heard a lot about? Is it speed of innovation? What is it? What is the sweet spot? If we were saying we wanted the United States was going to be energy independent in the next few years and we'd never be dependent upon anyone ever again, that we would then ultimately move off of the burning of dead animals and dead plants and all of the things that come from running 6 billion campfires, every second of the day. And so what is it? What is the sweet spot in this space where we could, in the United States, we could find a way where this cluster of know-how and manufacturing capability and unbelievable low-cost energy with low carbon footprints gives us just this advantage to be not just the leader of the economic competitiveness around the world, but give us the resources to continue to shape the positive outcomes for the world, because that's the other thing that we're trying to do. And so what is the sweet spot?
So for me, it's systems thinking. It's how you put everything we've got together. We have incredible advantages in terms of, we're blessed, as you were alluding to, with low-cost natural gas these days, which is just a tremendous fundamental thing for us. But in my view, we're going to need all the elements of all the fuels and non-fuels that we have. So nuclear, coal we're going to have for some time to come. Natural gas is going to grow, I think, quite fast. Wind and solar are coming on. You need a system that can handle all of that stuff. So being able to put that into a system that's effective is a real opportunity for us. And I think the United States, more than anywhere, is positioned to do very well. We have all those elements. We have high-quality systems to work from, and I think we can do it as no one else can.
Okay, Chuck?
I believe that if you look at the pace of innovation today, and because it's a global scale, your sources of solutions are coming from so many varied places. I think that the solutions are starting to outpace our ability to integrate them. And so my view is that actually the way we do science and technology today is probably still not keeping up with the information revolution, the big data revolution that's occurring. We're still human beings. We still operate a certain way, and we're not computers. We have our assistants in terms of our computers, our laptops, or our iPads, but they don't help you. They help you, but they don't accelerate your ability to integrate all these new technologies. I think what we need to do is look at the next generation, the next wave of how we do open innovation. I think it's got to evolve beyond where we're at today. It's too slow. My ability to work with the university is weighed down by patent considerations, business case considerations. By the time the opportunity it comes and goes, sometimes it takes too long to get the implementation. So PPG is not a basic research company. We're an applied research company. Yeah. And so I really believe that the way we apply that technology is going to have to evolve.
Okay, so Ray?
Fundamentally.
I'll paint the picture of the lights and shadows. So the lights are, I think it's wonderful that the United States has a promising energy future, abundant energy, and can be linked to manufacturing and maybe bring some large-scale manufacturing back to the U.S. and enable us to do some things we haven't done for a while, and that relates to jobs and all those things. And that's very important. The shadows, I guess, are that my comments before about the integrated world. It is possible that through the energy independence that we have, that others may not, that we lose our way in terms of innovation. The necessity of invention, right? And so
we become lazy because of
you become a little bit complacent in terms of what is needed to move beyond the campfires and move beyond the dependence on natural gas or whatever the source of that energy is, and that other nations, and I'm thinking of China in particular, China's waking up to the fact that 350,000 people in Beijing are developing early respiratory and other related diseases because of the pollution in China. That's a non-sustainable path forward. So they're going to make changes. Like Mark said, it'll be a combination of nuclear and renewables and other things. So I think it's fantastic economically that we can see a good path forward. I also think it's risky that we not sit back as we tend to do as a nation sometimes. I think many times we work better when we're under pressure and rally to the charge. We need to keep rallying. And also that the last comment would be that integrated world, and then when we do achieve that independence, let's keep working with other nations around the world to develop those next generation solutions so that we can be part of that and help the world be a better place.
So we heard about systems, we heard about this integration across science that we're moving too slowly. That, in my view, by the way, is built heavily around the notion of the hero model in academia, that there's the one person and the one discovery that somehow is going to alter everything, and occasionally there is, but never by itself. And then this notion of cooperation and so forth. So it seems to me that one of the things that we lack, that one of the things that we've got to work on is that you guys are painting a fabulous picture about what it's going to take to continue to be successful. And then we have often, and I'm from this sector, we have these lagging educational institutions. Yes, they're still producing good people, they're producing good ideas, but they move slower than a Sonoran Desert tortoise in my backyard. And so they're not adaptive. In fact, they're anti-adaptive in many ways. And so one of the things that I think is really important for us to hit some of these targets in energy and manufacturing systems is also to alter the educational enterprises as dramatically as possible. That's something that we're certainly committed to. We have about 5 minutes left. I'd like to open it up for anything other than speeches from the audience. And so if there are any comments or questions that you'd like to direct to anybody about where we're headed and what's happening in this whole area of advanced energy and manufacturing systems integration, this is a rare opportunity to get a question on the table. So who's got a question? Yes, they're in the middle of the room. I see someone raising their hand.
What is the largest challenge you see with the supply chain that could support your leaps? I come from a small manufacturing making big parts for others.
Thank you.
Thank you.
Okay. Okay. Supply chain
Mark,
challenges.
you go first. Sure.
Yeah, so innovation. So this part of the onus is on us because we've asked our suppliers to do kind of do tomorrow what you did yesterday, just do it a little bit better all the time.
And cheaper.
And cheaper, definitely cheaper. And that's not enough anymore. What we really need is innovation to take the next big step up. And we're going to do it ourselves. We need our suppliers to be even ahead of us in pushing the envelope.
So you need more than incremental adjustment.
Yes, more than incrementalism,
Okay.
definitely.
Chuck or Ray? Anybody?
I guess what we'd like to try to achieve is in the economic environment that we've been in for the last few years especially, to be able to develop a secure supply base that small businesses in particular are...
Secure, you mean reliable?
Yeah, secure. Yeah, I don't mean secure in,
right.
in that security sense, but a reliable and stable base in the supply chain, especially at the lower tiers, because you are very sensitive to dramatic swings in funding levels, not even cancellations, really more delays of program decisions where we get you spun up and get ready for a program and there's a delay associated with it. So I think what needs to happen is actually a government, industry, and small business, large industry and small business understanding and partnership that everybody recognizes that the other two players here have issues and difficulties, and by working together, we can help resolve that, bring communication, transparency, and stability to the funding profiles so that we can then develop a stable funding profile for you, et cetera, et cetera. You know how that goes, because I think the susceptibility to funding profiles for small businesses is very difficult. From a larger business point of view, there's another problem, and that is for those of you who might be associated with other larger firms, and that is that oftentimes the defense component of the manufactured piece, the defense pie chart component of the component, is small compared to the overall. And so we have trouble driving the outcome because of being a small piece there. I think just partnerships and transparency can help in that regard as well.
You want to add anything or next question?
You've got a chicken and egg issue too with scale. Cost is such a major driver. And so when we're trying to develop new supply chains, it's a major issue. And I talk about this material, we talk about this materials revolution, and we're constantly looking for new materials. But you really have to strike a balance to really nurture these new and growing potential materials and supply chains. So it takes a different model perhaps because we just want the lowest cost. Well, that becomes a big impediment to your growth and scale, and so we have to resolve that.
Okay, time for one last quick question. There's a microphone somewhere, yeah.
Hi, Lloyd Jacobs, University of Toledo. What do any of you think is the impact of the unrest in the Middle East and in the Ukraine? How does that impact our ability to innovate, our ability to compete? It certainly dampens the spirit of our country.
Okay.
Oh, okay. So fortunately, while there are very difficult things going on here, this has not terribly disrupted the industrial world at this point, and I hope that it won't get to that point. So I don't see that in the short term in any way being a major influence. I hope it stays that way.
Anybody else?
I guess I agree with that. I think in that particular region, in the Ukraine and in the Middle East in particular, I don't see large supply base for either our corporation or products around the world. But take, for example, a different part of the world. Let's pick South Korea. Obviously, any kind of conflict on the Korean Peninsula, whether the North might, for example, send rockets into, even conventional rockets, into Seoul, you can imagine the devastating financial impact that would have globally because South Korea is such a producer of electronics components for the world. So, I mean, your point is well taken. We have a very interconnected world. I think the specific places that you picked may not be the highest impact. Oil-wise, yes, maybe other things, no. But there are places in the world that certainly are susceptible to that in a big way.
Any escalation is going to cause an interruption in what we're doing. At the current level, PPG's operating basically the same as was just mentioned. We still have our relationships. We are opening a plant in Russia. We continue to follow our customers around the world, and they're globalizing. Russia's a huge market that all of our customers want to participate in. So we are following them, but currently we're continuing, but we have a cautious eye out to the future, and we want to ensure de-escalation, not escalation.
I know we're out of time. If I could add just one more thing. Probably I would be more concerned about the global financial impact of the impression and people being risk adverse to spending and making capital improvements and things like that, as opposed to a particular supply chain issue.
So with these great scientists and engineers, our panel's ending on time, so thank you.
Well done. Very well done. Thank you.
Okay.